Alright, this time we're checking even and odd functions again. You can be even function, you could be an odd function, or you could be neither. So in this case, and this one I should point out also, they're being dirty. The constant terms are actually x to the 0 terms, which is an even term. So I look at this and I suspect that this is an even function right out the gate, which it will be, and we're going to show it though. So how can you intuitively get an idea on whether it's going to be even or odd? For basic polynomials, if all of the powers are even, the function will kill the negative, and then f of negative x will equal f of x, and so it's going to be an even function. In practice, how do we actually do this? We have to check every time f of negative x. So when I put that in there, negative x to the 4 minus 2 negative x squared plus 3. The x to the 4 kills the negative, the x squared kills the negative. So this will be x to the 4 minus 2x squared plus 3. That was my original function, so this is f of x. So f is even by definition, because f of negative x equals f of x, and therefore it's symmetric with respect to the y-axis. So now we have the category of where I suspect it might be neither, because what we noticed with the odd function is it had odd powers, and so I could pull the negative out of the function, and then that showed it was odd. For an even function, if all the powers are even, then it will kill the negative, and then it'll absorb this, and this function seems to have both even and odd powers, so it's going to be neither, most likely. I have to check using the definition though, so the first move is f of negative x. I put negative x wherever. This will be the hardest one for you to argue at first, because nobody shows you how to argue things when things don't work out. If it works out and it's odd, then you're like odd. If it works out and it's even, you're like even. But what does it look like, and how do I argue when it's neither of those? So first I calculate. This is negative x cubed minus negative x squared plus negative x minus 1. The odd powers are going to spit the negative out, the even powers are going to absorb them. So this will be negative x cubed minus this negative will go away, x squared, and minus x minus 1. So it turns out I got all minuses in that case, and I can write that as negative, if you want, x cubed plus x squared plus x plus 1. But now here's what I'm going to do. I say that's not equal to f of x, and then they'll say that's also not equal to negative f of x. How do I know that? Well, I have f right here. So I go and I look at it for a second, and I say my original f has 2 negative terms. This one has all negative terms, so it can't be f of x. And if I looked and actually calculated that, what would negative f of x look like? It would look like negative x cubed plus x squared minus x plus 1. So it still has 2 negatives and 2 positive terms. This one has all negative terms because of the negative distributive in there. So I can tell that both f of x and negative x have mixed terms. 2 of them are negative and 2 of them are positive, but the calculation I made, f of negative x, has all negative terms. So it can't equal f of x, and it can't equal negative f of x. So this function is neither even nor odd.